Right now, an object older than Earth is racing through our solar system, and Michio Kaku says it's one of the most important things we've ever seen. It didn't form around our sun. It didn't grow up alongside our planets. It came from another star system. Its name is 3I Atlas, and scientists around the world are watching it closely. This is not science fiction, it's a real interstellar comet carrying material billions of years old, a frozen messenger from deep space moving too fast to ever return. So why does this matter? Because objects like this may hold clues about how stars form, how planets are built, and whether the ingredients for life are common throughout the galaxy. To understand why physicists are paying such close attention, we first need to understand what 3I Atlas actually is, and what makes it so unusual. 3I Atlas is what scientists call an interstellar comet. That means it did not originate in our solar system. It formed somewhere else in the Milky Way and was later ejected into interstellar space. Only a handful of such objects have ever been confirmed. Most comets we observe are gravitationally bound to the Sun, following long, looping orbits that bring them back again and again. 3I Atlas, its trajectory shows that it is just passing through, a visitor, not a resident. Michio Kaku has described it as a rare scientific opportunity. Unlike earlier interstellar objects, this one is relatively bright and active, making it easier to study with modern telescopes. Multiple observatories are tracking its motion and analyzing the light it reflects and emits. From that light, scientists can determine its speed, its composition, and how it reacts as it approaches the Sun. What they're seeing is both familiar and strange. Familiar because it behaves like a comet. Strange because it becomes active much earlier than expected. That early activity is the first sign that something unusual is happening. One of the main reasons physicists are so interested in 3I Atlas is its path through space. Unlike normal comets, it follows a hyperbolic trajectory. In simple terms, it is moving too fast to be captured by the Sun's gravity. After it passes through our solar system, it will continue onward into deep space, never to return. This confirms its interstellar origin beyond any reasonable doubt. Michio Kaku has emphasized that this motion is entirely natural. There is no evidence of artificial propulsion or advanced technology, only gravity and momentum shaped by events billions of years ago. Objects like this are thought to be ejected from their home systems through powerful interactions with massive planets or nearby stars. Once freed, they can wander the galaxy for immense spans of time. For scientists, this trajectory tells an important story. It suggests that planetary systems across the galaxy are dynamic and sometimes violent, capable of flinging material far into interstellar space. 3I Atlas is physical evidence that this process is not rare, only rarely observed, but its motion is only part of the mystery. The second reason 3I Atlas captured so much attention lies in its chemical composition. By studying the light it emits, scientists have detected familiar cometary materials, including compounds related to water. But they've also observed activity at distances where most comets remain dormant. This suggests that some of its ices are more volatile, or that its surface has been altered by long exposure to cosmic radiation. Michio Kaku has pointed out that interstellar space is an extremely harsh environment. Over millions or even billions of years, radiation can chemically modify a comet's outer layers, creating complex organic molecules. These compounds are not signs of life, but they are important. Similar materials are believed to have played a role in delivering the building blocks of chemistry to early Earth. In that sense, 3I Atlas may represent the kind of raw material that helps shape planets, not just here, but everywhere. What scientists are still investigating is how closely its chemistry matches what we see in our own solar system. If the similarities are strong, It suggests that planetary systems across the galaxy may form in broadly similar ways, and that leads to a much bigger implication. The most important insight from 3I Atlas isn't just about this single object, it's about what it represents. Physicists now believe that interstellar objects may pass through planetary systems far more often than we once assumed. Most are simply too small or too faint to detect. As detection technology improves, more of these visitors will likely be discovered. Michio Kaku has described objects like 3I Atlas as time capsules, preserved fragments from distant star systems, carrying information about environments we may never visit directly. This changes how we think about the galaxy. Space is not empty or isolated, it is connected by a slow exchange of material, drifting between stars over cosmic time. The same processes that shaped our solar system may be shaping countless others. 3I Atlas is proof that these systems are not separate stories. They are chapters of a much larger one. So why does this matter beyond astronomy? Because understanding objects like 3I Atlas helps scientists address some of the deepest questions we can ask. How common are planetary systems? How universal is chemistry? And how often do the ingredients for life appear? This comet doesn't answer those questions on its own, but it provides real data, not speculation, from beyond our solar system. That's why physicists are watching it so closely, not because it's dangerous or mysterious in a sensational way, but because it is scientifically rare and deeply informative. It reminds us that discovery is still happening, quietly and methodically, driven by careful observation rather than hype. 3I Atlas will eventually leave our solar system, continuing its silent journey through the galaxy. But the data it leaves behind will be studied for years to come. As Michio Kaku often reminds us, science advances not through dramatic claims, but through careful evidence. And this object provides exactly that. If you enjoy calm, thoughtful explorations of space and physics, consider subscribing and turning on notifications. Here, we explore the universe not as speculation, but as a story written in data, observation, and wonder. Thanks for watching. And as always, keep looking up. What do you think, 3I Atlas? Share your thoughts in the comments below.